Hi, this is the first in a series of notes on dealing with integers. Today's objective is going to be dealing with addition of integers using pictorial models and a number line. Our essential question for today is, how can we model addition of integers? Now let's begin with our first example. Here I have an example and it says, use a pictorial model and a number line to model the following expressions. And we're given expression A to be 2 plus 4, and expression B is negative 3 plus negative 2. Although we know the answers to these, the assignment really is, can we model or demonstrate how we get the answer? And that's exactly what we're going to do. It's a pretty straightforward and easy process. Let's begin with A, 2 plus 4. Now intuitively we all know that 2 plus 4 equals 6, but we're going to use pictures to prove it. What I'm going to begin with is I am going to turn this expression 2 plus 4 into a picture diagram. So what I'm going to do is I'm going to draw two circles with plus signs to indicate positive 2, which is what the first value is in my expression, being joined with or added to four positives or four circles with plus signs in them. So I have two positives and four positives being joined, which is what addition does. And just as we suspect, when we join two positives and four positives, we get six positives. Pretty straightforward, pretty easy, not too hard to do. And it works the same way with any two positive numbers. When you join two positives, you just get more positives. Now let's go ahead and model this with a number line. I'm going to draw a page break in my notes and then kind of scroll down a little bit and begin with a number line. Here is one example of a number line. In this number line, I have 0 and then I have positive numbers 1 through 6. We do know that there are numbers to the left of 0 which are negatives, and there are numbers greater than 6 which are indicated on this number line with these arrow tips. But for the purpose of our example, we're only going to deal with 0 to 6 range. So go ahead and construct this number line now. And once you've constructed this number line, we can go ahead and begin modeling the same expression that we had above, 2 plus 4. You always start at 0 when you model on a number line, and we will go to the value of our first number, which is 2. Since it's a positive 2, I'm going to go 2 spaces to the right of 0 and end up right here at positive 2. I'm going to draw a little line showing that I stopped, and this little arrowhead shows the direction I came in. I started at 0 and I came to the right 2 whole units. Now with this line, I'm going to join another segment. This next line segment will begin exactly where I left off at positive 2 and go 4 spaces in the positive direction because it's a positive 4. So I continue on 1, 2, 3, 4. I make a line to show that I stopped and an arrowhead to show the direction I traveled. I came from 2, I went 4 steps to the right and landed here. Now we can see our answer. When we join the first line segment positive 2 and another line segment positive 4, we really end up with just one really long line that's 6 units long, positive 6 units long to be more specific. So 2 positives plus 4 positives gives us 6 positives, just like we had above, and our answers should correlate if we did our math correctly. Now let's move on to example B. On the right hand side, I have the expression negative 3 plus negative 2. Now for this model, I'm going to go ahead and write it a little differently in the way that I stacked it. I put 3 negatives, which are 3 circles with minus signs or negative signs in them, and then I'm going to join those with 2 more negative circles. And just as suspected from the previous example, when you join 3 negatives and 2 negatives, you end up with 5 negatives, a grand total of negative 5. Pretty easy. Whenever you add negatives to more negatives, you just get a whole lot more negatives, just like with the positives. Pretty easy. Now let's go ahead and model this example with a number line. So I will begin with a number line. Now this one, I have 0 on the right hand side, and most of my digits are to the left, are negatives, because I know I'm dealing with a lot of negatives. So I have from positive 1 to negative 5 as evenly spaced as I could do it. Go ahead and construct a number line similar to this now. Once you have that done, we can begin with the diagram. And just like in the previous example, I start at 0 and then I go to the value of my first number, in this case negative 3. Negative 3 means I'm going to the left of 0 3 steps. So I start at 0 and I go 1, 2, 3. I put up a little wall to show that I stopped and an arrowhead to show the direction that I traveled. In this case I traveled from 0 to the left 3 steps. I'm going to add to this line another segment that is 2 units long, also in the negative direction. So exactly where I stopped right here, I pick up and begin my new line, and I go 1, 2 more units to the left. I draw a line there to show that I stopped, and an arrowhead to show the direction I traveled. So I had a segment of -3 joined by another segment of -2. And just like before, we now have basically one line that extends from 0 all the way to -5, which corresponds to our answer above when we used the chips, the integer chips, or the diagram above. So if you have this right, both answers should correlate. Let's go ahead and begin now, or turn your page over to do the second set of notes.